Hi, this is transportation journalist Eric Adams. About a week or so ago, I achieved a bit of a personal dream by finally taking the controls of a real live helicopter. It wasn't a little Robinson trainer or anything, but this twin-engine 12,000-pound Sikorsky S-76. Now, I don't actually have a pilot certificate, nor did I even have to go to flight school to take over this thing. All I had to do was whip through about 45 minutes of instruction and go climb aboard. See, this is the world's first autonomous helicopter, meaning all you have to do is tell it where you want to go via tablet computer, hit execute, and it does all the work for you. It's called SARA, for Sikorsky Autonomy Research Aircraft. And it's being developed by, obviously, Sikorsky at the company's Stratford, Connecticut headquarters, and I was actually the first journalist to fly. Of course, I was accompanied by an actual pro, Sikorsky's chief test pilot, Mark Ward, who's a former Coast Guard pilot who's helping develop this program with a team of engineers, all led by Chief Autonomy Engineer Igor Cherepinski.
Now, this is an experimental aircraft. It's a flying laboratory. If we didn't like something that was happening, we would disengage the system and I would fly it just like a conventional aircraft.
Right.
But if I were to grab hold of the flight controls while it's coupled, it'll also disengage the aircraft.
Okay.
That's a safety feature. When you want to influence what's happening in the autonomy system, you get on these sensors.
Okay. Now, this is a hugely important project because it could prove essential to our future of aeromobility, enabling the many visions of personal electric aviation and on-demand electric air taxis that we're seeing all over the place. Sikorsky just announced it was entering the air taxi market last week at an industry trade show called Heli Expo, and this is a big part of that effort, along with the company's data management systems and its electric propulsion efforts. Now, for air taxis to succeed, they'll need to be in the air by the thousands, and pilots are already in short supply across all categories of aviation. So autonomy will be key. The aircraft will need to map out their routes, communicate with air traffic control, and avoid everything from power lines to birds to other aircraft. All that, of course, and actually fly the helicopter at the same time. That is, successfully control its movement through the sky in accordance with all the rules of physics, aeronautics, and aerodynamics. Now, that's all down the road, of course. More immediately, Sikorsky will use its so-called matrix technology to reduce pilot workloads and improve safety in a variety of current helicopter operations, from routine flight to nighttime search and rescue missions at sea. It does all this via an array of sensors, including cameras, accelerometers, and laser-based LiDAR sensors, with all the data crunched through a supercomputer aboard the helicopter. It also comes with a pair of controllers, so you can interrupt autonomous flight to change your position and direction while on a mission. They don't replicate conventional helicopter controls, that is, with a cyclic, collective, and pedals, but rather are simply a joystick and throttle controls called inceptors that let you aim the chopper where you want to go. The computer interprets your inputs and makes the change.
In a hover, here's your sense. This is left and right, forward and back. Okay? This is up and down and yaw, left and right.
All right.
Right? So the yaw is...
Right here?
Yep, exactly. You pull it towards yourself to rotate right, clockwise, however you like it. As soon as you let go.
Now, the LiDAR, or the laser scanners, are positioned in the nose and in the rear of the aircraft, and the cameras and radar sensors are distributed around the outside as well. Inside is a supercomputer that processes all the data for the flight control system.
So remember, this aircraft has sensing, right? I mean, the big thing about helicopters. So you'll see there's 3 LiDARs and cameras and all that stuff around the aircraft. So this mesh on the ground you're seeing is essentially a quick representation of what the system thinks it's seeing. It's merged between DTAD, right? So a priori kind of digital terrain, plus what the LiDAR is seeing, and it works much better in real life. You'll be able to see like measure the buildings. But long story short, anything that's green is far enough below that you don't have to worry about it. You know, there's like this bump in DTAD data right here that's near your altitude and saying, hey, around here there might be an obstacle, and the planning system will actually plan around it. And these blue circles are landing zones, so it constantly searches for viable LZs.
Okay.
So as you fly around, look at the blue circle, especially when you're not here like outside, because obviously here it's going to find lots of them.
Right. Now, making helicopters autonomous is a huge challenge, much greater than even for airplanes. Fixed-wing aircraft typically have very straightforward takeoffs and landings into known airports, but vertical lift aircraft, whether today's helicopters or tomorrow's air taxis, must be able to manage tricky landings and takeoffs in tight settings, such as amid trees or on urban rooftops with wild gusts of wind buffeting them from every direction. They fly much lower than regular aircraft and have a lot more to deal with. My own flight, though, was a snap. All we had to do was lift off and hover at 60 feet, reposition the helicopter to 2 different points on the airport, and then fly off to a point about 10 miles away before returning for some additional maneuvering. My job was to make it all happen, something I did via that tablet controller and the 2 inceptors, the hand controls. It was, frankly, a lot like a video game, with all the actual hard stuff of helicopter control stripped out as if I'd simply checked a box in a settings menu somewhere. Now, flying helicopters is ordinarily extraordinarily difficult, with beginner pilots requiring hours of training to simply learn how to maintain a steady hover, let alone shuffle across an airport at 60 feet. But with Matrix, I did it instantly. Now, on our actual flight, we flew up to about 1,500 feet, past the Housatonic River and over the rolling Connecticut countryside. Even at high altitude and with stronger winds, the helicopter remained steady and responsive, heading in whatever direction I asked. I banked easily over cell towers and maneuvered across the landscape like a grizzled helicopter veteran. There was no wrestling with the sensitive controls or struggling to maintain my position. The helicopter did everything, and all I had to do was tell it what I wanted to do next. Now, we also hear a lot about automotive autonomy these days, and the 2 technologies are actually pretty different. Whereas autonomous car programs are using machine learning to train cars over millions and millions of miles to manage every conceivable challenge, Sikorsky is instead simply telling the aircraft what to do in each case. For their needs, it's faster and it's more precise. At the moment, in fact, the greatest remaining challenge for Sikorsky is simply nailing the user interface, which is still very much a work in progress. At the moment, that interface is still oriented toward professional pilots, but in the future, versions of this system will be even simpler than what I experienced, with interfaces designed to allow operators with no aviation knowledge whatsoever to simply tell the computer where they wanted to go, via taps or even voice controls. It will steer clear of danger, follow the rules of the sky, and respond instantly to threats, whether in the shape of other aircraft or birds or errant gusts of wind. Though truth be told, that's really pretty much what SARA is already doing. And Ward says that once pilots get a taste of it, they're going to immediately appreciate not only the way it's able to take over the flight completely, but also just reduce their workload in their day-to-day operations and in tricky missions where they have to divide their attention between flying the aircraft and executing the mission.
I'm really excited about this, by the way. I'm 20 years a Coast Guard helicopter pilot, retired, flew in some crappy weather, been scared many times. If I had a system like this, life would have been, I could have been so much more effective in different cases. So it's exciting stuff.